In this Blender tutorial, we'll create the scene from scratch. We'll be modeling the wall and the floor, assigning materials to all objects, positioning the lights and the camera in the scene, and finally rendering the scene with the Cycles engine. This tutorial is a practical example of how to use Blender to create scenes. You can follow it step by step to recreate the scene yourself. Navigation in the 3D viewport is customized, so if you decide to follow along, use your own preferred keystrokes. We use the Machine Tools add-on to quickly switch between modes in Blender. The tutorial is split into two parts. First, we model the objects and build the layout. Then, we add materials, set up everything, and render the scene using Cycles. Let's get started. In the outliner, create a new collection and rename it to Meshes. Move the default cube to the new collection. Hide the camera and the light from the scene. Now, we are going to create the base for the monkey using the Blender cube. Select the cube in the viewport. Press N to open the right panel. Select the Item tab. Scale along the Z-axis using the keystroke sequence S, Z, 0.5, Enter. Next, scale along the X and Y axes using keystroke sequence S, Shift, Z. Scale until the dimension reaches 2.77 meters. Press Ctrl A and select Apply Scale. To position the cube at ground level, set the object's origin to the bottom face. Then move the object to the origin of the coordinate system, where the cursor is located. Switch to Face Edit mode and select the bottom face. Press Shift S, then choose Origin to Face. Return to Object mode, press Shift S, then choose to Cursor Offset. To create a chamfer on the edges, switch to Edge Edit mode. Press 8 to select all the edges. Press Ctrl B to bevel, then click to confirm. Finally, return to Object mode to add a monkey mesh. Press Shift A, select Mesh, choose Monkey. To place the monkey on the base, switch to the right orthographic view. Select the monkey, press the sequence GZ. Put the monkey on top of the cube. Click to confirm. To settle the monkey on the surface, press R and adjust the tilt. S to scale properly. To smooth the appearance of a monkey, right-click, select Shade Smooth. Since the monkey's appearance isn't smooth enough, let's double the mesh resolution. Go to the Modifiers tab in the Properties panel. Add a Subdivision Surface modifier. One level of subdivision is enough. Orbit around the monkey to make final adjustments. Before modeling the floor of our scene, let's hide the visible objects. To make the floor, we're going to add a plane. In Object mode, press Shift A to add a mesh. Select Mesh, choose Plane. Switch to the top orthographic view. To scale to double, press S followed by 2. To subdivide the plane, go to Edge Edit mode. Press 8 to select the entire square. Right-click and select Subdivide. From this mesh, we create the tile. The goal is to create a thin cube and remove the areas marked by the edges. To achieve this, firstly use a Solidify modifier on the plane. Secondly, use a Boolean modifier with a cutting object. Let's create the cutting object. Select the inner edges. Press P to open the separate menu. From the options, pick Selection. Now select the outer edges. Press P to separate. Choose Selection once more. Go to the outliner and temporarily hide the plane from the 3D viewport. Return to Object mode. Now let's join the edges into a single object. Select the separated objects and hit Ctrl J to make a single object. The last operation merged the two objects into one, but kept the meshes separated. Now we can merge the meshes into one. Select the object and return to Edge Edit mode. Press 8 to select all edges. Press to bring up the Merge menu. Select by distance. Enter 1 mm to merge the vertices that are within that distance. Return to Object mode. Press F3 to open the search bar. Select Convert to Curve. Now go to the outliner and display the plane in the viewport. Select the plane. Go to the Modifiers tab in the Properties panel. Add a Solidify modifier. Enter a thickness of 5 centimeters. Return to the outliner and select the curve created earlier. Go to the Data tab in the Properties panel. Go to the Geometry section. Locate Depth. Inside Bevel section, enter a thickness of 1 centimeter. Make sure in the viewport that the edges have indeed gained volume. Increase the resolution to 8 to give more geometry to the circumference of the curve. To smooth the appearance, press right-click and select Shade Smooth from the menu. To use the cutter object with the Boolean modifier, we need to first convert it into a mesh. Press F3 to open the search bar. Select Convert to Mesh. Go to the outliner and rename the object to Cutter. Next, select the tile. In the Modifiers tab, apply the Solidify modifier to the mesh to make the changes effective and permanent. Then, add a Boolean modifier and set Cutter as the difference object. Looking at the viewport, the tile has disappeared. This indicates that the Boolean operation has not been successfully applied. We need to check the mesh of the cutting object to make sure there are no unfilled faces. Select the cutter. Switch to Face Edit mode. With the mouse hovering over the mesh, press L to select a full mesh. As you can see, only a portion of the mesh was selected. Press L again on an unselected area of the mesh. The previous merge operation didn't create a single mesh. Let's check that there are no open meshes. Select the first mesh by pressing L. Right after, press P to bring up the separate menu. Click on Selection. In the outliner, hide the first cutter. Now select the second cutter and switch to Edge Edit mode. If it's hard to orbit around the object, select any edge and press Numpad 5 to switch to orthographic view. The caps of the cylinder are not closed. Hold Alt and click on one end to select the edges of the ring. Press F to fill. You might notice that the face doesn't look right. The shading is off. To fix the shading, select all the edges of the ring again. Right-click, select Mark Sharp. Follow the same steps to fix the other end of the cutter. Once the mesh is fully closed, we can combine the cutters back into a single object. Switch to Object mode. In the outliner, unhide the invisible cutter. Select both cutters and join them by pressing Ctrl-J. Now let's try the Boolean operation again. Select the tile. Go to the Modifiers tab. In the Boolean modifier, set the cutter as the operand object. This time, the operation was successful. In the solver options, tick both boxes. Select the cutter in the 3D viewport and hide it by pressing Ush. Select the tile again. In the Modifiers tab, choose to apply the Boolean. After inspecting the new geometry of the tile, we can see that the result of the Boolean operation wasn't quite right. Some extra faces need to be removed. Review the mesh, and in Vertex Edit mode, delete all the unwanted vertices. Select the vertex or group of vertices. Press X to open the Delete menu, and then hit V to delete the vertices. We can even use the Lasso Selection tool combined with Occlusion mode to delete vertices with uneven distribution. This tool is flexible and speeds up selection. After fixing the exterior of the mesh, we notice that there are also issues in the center. We need to delete those extra vertices, just like we did before. In this particular group of vertices, we can see that there are duplicate vertices, arranged one behind the other. With the Machine Tools add-on, we can use the Cleanup tool to instantly fix the geometry issues. Press the number 3 on the keyboard. As we can see, the duplicate vertices have been removed. Carefully remove the remaining extra vertices. After a final check, we can see that the tile is now perfect. Before creating the floor, make a duplicate of the tile to preserve the original object. Go to the outliner and select the tile. Press Shift-D to duplicate. Hide the original object and rename the copy to floor. We'll build the floor using array modifiers. The array modifier allows us to create repeated copies of an object in a chain-like formation. We can control the number of copies, the distance between them, and the axis along which they are placed. Go to the Modifiers tab and add an array modifier. Increase the number of copies to 6. By default, the array modifier operates along the x-axis. To extend the floor along the y-axis, you can't simply adjust the same array modifier because, as you can see, the copies are made considering both axes simultaneously, which is not the desired result. Next, we need to add an additional array modifier. Set the relative offset to 0 along the x-axis and 1 along the y-axis. For the number of copies, choose a value that suits the desired size. To smooth the shading between tiles, right-click and select Shade Auto Smooth. To add realism to the floor, we'll apply a bevel modifier with a 1 mm width and 3 segments. If you're following the tutorial step by step, be sure to place the bevel modifier after the array modifiers and before the auto smooth. We can preview the changes by toggling the modifier on and off. After applying the bevel modifier, we'll add one final modifier, Weighted Normals. This modifier is used for hard surfaces to adjust the vertex normals based on the size of the faces they belong to. To better visualize the effect, we can enable a matte cap. By turning on Weighted Normals, you'll notice that the invisible adjustment to the vertices normals creates a smoother and more even light reflection across the entire surface. Make sure to place this modifier right after the bevel modifier for the best result. To finish up, switch to Object mode, go to the Modifiers tab, and apply each of the array modifiers. With the changes now applied to the mesh, let's place the object's origin at the center of its geometry. In the viewport, select the floor and press Shift-S, then choose Object Origin to Geometry. Next, let's reposition the floor to the global center of the scene. Press Shift-S again, and pick the cursor offset. To finish up this part, unhide the base and the monkey. Orbit around the scene to ensure everything looks correct. Hide the objects to keep the workspace clean. Now let's start building the wall. Press Shift-A to add a plane. Choose Mesh Plane. Switch to Top Orthographic View. Select the plane in the 3D viewport. Press S to scale, then type 2 to double its size. Go to the Modifiers tab and add a Solidify modifier. Increase the thickness to 5 centimeters, then apply the modifier to make the changes permanent. Go to the outliner and make the base visible again. Select the plane and press R to rotate, X to lock the rotation to the X-axis, then type 90 to set the angle. Press Enter to confirm. Now hide the base by pressing Ush. Switch to Edge Select Mode. To select the edges on the left side, hold Alt and left click. Then press Ctrl B to create a bevel. Use the mouse to adjust the size and the number of segments. Press P to change the profile from convex to concave, then confirm with left click. Switch to Face Select Mode, select the back face and press X, then choose Only Faces to delete it. Return to Object Mode. To smooth the shading of the bevel, right-click and select Shade Auto Smooth. In the Modifiers tab, add a bevel modifier with a 1 mm width and 3 segments. Then, add a Weighted Normals modifier. Make sure the modifier stack is in this order: bevel, then weighted normals, and finally auto smooth. We now have the wall tile. Let's duplicate it using the outliner. Press Shift-D to create a duplicate. Rename the new object and hide the original. Select the duplicate and go to the Modifiers tab. Add 2 array modifiers, the first with 6 copies along the X-axis, the second with 2 copies along the Y-axis. Notice in the viewport that the object is rotated along the X-axis, causing the Y-axis to now align with the vertical direction. Mentally rotate the gizmo 90 degrees around the X-axis, and you'll see that the Y-axis becomes perpendicular to the horizontal plane. This is why, in the second array modifier, we don't use the Z-axis as a factor. Now, let's apply the modifiers to make these changes permanent. Rename the object to Wall. In the outliner, unhide the floor so it becomes visible in the viewport. Select the wall in Object Mode. Press Shift-S and choose Origin to Geometry. Press Shift-S again and select the cursor offset. Now, both objects are aligned at the center of the global coordinates. Unhide the monkey in the scene. Switch to the right orthographic view. Select the wall, then press G followed by Y to move the wall and align it with the edge of the floor. Switch to the front orthographic view and press G followed by X to align the joints of the tiles. Switch to the top orthographic view, then press G followed by Y to close any gaps and ensure a seamless connection between the wall and the floor. Orbit around the scene to confirm that everything looks correct. Finally, to elevate the wall vertically, press G followed by Z to restrict the movement to the vertical axis. Switch to the left orthographic view to make the final adjustment. And with that, we've completed the first part of the scene. In the second part, we'll assign materials, adjust the positioning of the camera and lighting, and render the final image. The Blender file for this lesson is available for download to all Mundo Blender subscribers at Ko-fi.com. If this is your first time here, make sure to subscribe to the channel. Feel free to leave your suggestions, questions, or feedback in the comments. We've come to the end. Thanks for watching. Have an awesome day, and see you in the next one.